We're on page 6 of the chapter 13 packet, and we'll discuss probability with permutations. First, we'll discuss what a permutation is. A permutation is an arrangement of objects where order or position matters. Order or position matters. In discussing permutations, we have to go over a concept called a factorial. And so the number of ways to find a permutation or ordering of group n objects, you'll need to find factorials in it. And so when we take a factorial, we'll use 5 factorial as an example. The number preceding the exclamation mark is the number you would start with, and you would find the product of that number and one less than that number and decrease that and continue to find the product of those numbers until you get to 1. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1, and that would lead us to 120. So in the first example, in Sierra's summer swim league, there are 6 swimmers in each heat, and every swimmer in each heat gets a ribbon. How many different ways can 6 swimmers finish in first through 6th place in their heat? So in this example, because order matters, we would take 6 and multiply by 5, because there would only be 5 after the first selection. There would be only 5 left to pick from, then 4, then 3, then 2, then 1. To summarize that, we say 6 factorial, which is 720. Sometimes, however, you have a larger group in which you want to find the possibility of the orderings of a smaller group. So if that example had said there are 8 swimmers in the finals of the Olympics, in how many ways can 8 swimmers finish in first, second, third place? First, we know that the order matters because there is a ranking involved, first, second, and third place. This time, however, we have 8 swimmers to choose from and not 8 awards to give, only 3 awards. So if we first think of it just without the factorials, this would mean that there's 8 swimmers to pick from for the first prize, then 7 because the first person has already been selected, then 6. So that answer gives me 336. This is where the formula below that I'll circle comes from. So another way of finding 8 times 7 times 6, or summarizing this permutation, is writing the 8 for the total number of people to choose from, and then P for permutation, and then 3 for the smaller group that's being selected, in this case for the gold, silver, and bronze. So 8 on top would be 8 factorial divided by 8 minus 3 factorial, or the difference between that, because we want to get rid of the 5 times 4 times 3 times 2 times 1, since the permutation only includes 8 times 7 times 6. So in this case, we get 8 factorial over 5 factorial. And we can think of 8 factorial as 8 times 7 times 6 times 5 factorial. And since we already have the 5 factorial on the bottom, those cancel out and we get 8 times 7 times 6, which is the same as the value that we have on the left, 336. So once again, that permutation that occurred right there, the formula is below. It just confirms that that's one technique to use to find the orderings when the arrangement does matter, when position does matter. So now use this formula to confirm your answer from the last example. We just did that. And so let's take a look at what happens when you have distinct versus non-distinct objects. So in the first question, how many ways can you order the letters A, B, and C? So we're going to come up with just what the sample space would look like so you have a visualization of this. So if I were to list out all the possible ways, ABC would be a possible outcome, ACB, BAC, BCA, C first, AB, and then CBA. So there's a total of 6 possible outcomes. We could have come up with that because there's also 3 different letters to choose from. So in our previous video, we talked about first having 3 options to pick from, and then 2, then 1. So the permutation of 3 is 3 factorial or 6. And so that tells us all the possible outcomes that we have right there. Now, what happens if the letters have a repetition in it? Like, for example, mom. Okay, we have 2 M's there. So our possibilities, our sample space for that would be MOM, or we could have O first and then MM. But if we think about these 2 M's being switched, it wouldn't matter because it still spells the same thing. So we only list that once. And then same thing for if the M's came first, then the O's. So for this case, we have a possibility of 3 different outcomes. So the second's different because not all the letters are distinct. So this is considered a non-distinct situation. So when that occurs, you're going to take all the possibilities that you have, in which case that's 3 factorial or 3 times 2 times 1 because there's 3 different options to pick from. So n factorial, and then you divide by the number of times that a certain, in this case, letter is being repeated or object is being repeated. So we'll call that first repetition 1, r sub 1 factorial. And then if there's more letters within the first initial problem that's being repeated, we would continue to divide by however many of those letters are being repeated, and so on and so forth. So I'll just put etc. here. So in that example above there, you had 3 letters to pick from, M, O, and M. M is being repeated, and M has 2 letters. So we would divide by 2 factorial. And so 3 is also 3 times 2 factorial. So the 2 factorials cancel out, and our answer is 3. Or you can think of it as 3 times 2 times 1 is 6. 6 divided by 2 times 1 is also 3. So when I'm looking at arranging letters, let's look at how many ways can you order the letters rearranged. So we see that we do have non-distinct letters, meaning that there's some letters that are repeated. So first we count how many letters we have. We have a total of 9 letters. So the top would be 9 factorial. And it would your answer would just be 9 factorial if there was no repetition of letters. However, we have 3 R's that are repeated. We have 2 A's and we have 2 E's. So what we do is we divide out the outcomes in which are repeated. So 3 factorial, 2 factorial, and 2 factorial. So if I were to simplify this out, I would have 9 times 8 times 7 times 6 times 5, 4, and then 3 factorial is repeated on the bottom, so I'm not going to even write that out because the 3 factorials are going to cancel with each other. So this 3 factorial and this, they're factors, so we can cancel. And then if you divide by 2 factorial times 2 factorial, which is 4, we get there's 15,120 different options. Now, if we do the same thing with Mrs. Springer, go ahead and hit pause and see what you guys get when you try this one. There should have been a total of 11 letters. So 11 factorial divided by 2 for the 2 repeating S's. And then R also repeats 3 times, so 3 factorial. So this one's for the S, this one's for the R. And if we divide 11 factorial by 2 times 1 times 3 times 2 times 1, which is 12, we get a possibility of 3,326,400 possible ways you can order those letters.